Hello, this is Mr. Bainey, and this lesson is 3.3, Interpreting the Unit Rate as Slope. The standard, 8 EE.5, and the essential question, how do you interpret the unit rate as slope? So we're going to continue from last lesson where we're dealing with rate of change and slope, and then they're throwing in this new thing called unit rate, and really it is the same thing, especially when we're dealing with proportional relationships and constant proportionality. So unit rate is going to be vital in working with our word problems. Okay, finding unit rate is going to be very, very important. So first, here is our definition of unit rate. If you'd like to read that, let's try the explore activity. So a storm is raging on Misty Mountain. The graph on the right shows the constant rate of change of the snow level on the mountain. So we're going to find the slope of the graph using points 1, 2, and 5, 10. So I'm going to mark those. 1, 2 is here in red, and then 5, 10 is way up here. So how do I find these points? Or how do I find the slope of these points? So look, the y is changing from 2 to 10, which means from 2 to 10, I'm going to subtract 10 minus 2 because I want to know how much is that rising. And then also I want to find out from 1 to 5, how much is that changing? So I take 5 minus 1. And so I get 8 on top and 4 on the bottom. And 8 divided by 4 is 2. Then we're going to find the unit rate of snowfall in inches per hour. So we want to know how much inches per hour means. This means how many inches in 1 hour. So per hour means 1 hour, really. So I could look at my graph, and in 1 hour, it's actually right here. That 1, 2, right? What does that mean? This means 2 inches of snowfall in 1 hour, or I could write per hour. So 2 inches per hour of snowfall. And the way we found that, I'm not going to write it down, is we're looking at specifically at the point. Notice that it also matches the slope that we got. Okay, and you're going to realize that we're going to be getting some of the same numbers here. Part C, compare the slope of the graph and the unit rate of change in the snow level. So I just noticed this actually, or I just mentioned it, is that slope and a unit rate are equal. They're the same thing. Part D, which unique point on this graph can represent the slope of the graph and the unit rate of change in the snow level? Explain how you found the point. And I already did it for you because if we're looking at per hour, it means 1 hour, then we're really looking at the point 1, something, right? That something is going to tell us how much of the y value, right? This is the y, happens in one unit of the x value. So in this case, 1 hour, right? So at the x-axis represents hours. The 1 is going to mean 1 hour, and it's the same thing as saying per hour. So this unique point is going to tell us what that slope is. The slope is going to be right here, or the unit rate, same thing. Okay. Next page. Let's go ahead and do the your turn at the bottom. So we're graphing proportional relationships here. We're also going to find the unit rate. Tomas rides his bike at a steady rate of 4 miles every 6 minutes. we're going to graph it and find the unit rate of this proportional relationship. So proportional, I mentioned this in the last lesson if you watched the video. Proportional means it goes through the point 0, 0. So I can just start right there all the time when it's proportional. 4 miles every 6 minutes. So I'm going to go 6 minutes, right? The bottom, the x-axis is minutes. So over here, 6 minutes. I'm going to go, so here's 6 minutes. And then 4 miles. So up here, I'm going to do that point. And here's my graph. Okay, it's not a graph unless you actually connect this and make a line. So I have the point 0, 0 and 6, 4. So I'm done with the graph. Now let's find the unit rate. The unit rate. So this is going to be a little tricky. The unit rate in the proportion in only proportional relationships is going to be the change in y divided by the, well, it's really the y divided by the x, right, which is the same as k. If you remember that all the way from the, where is that from the first lesson, 3.1. So our y coordinate, let's look over at the graph over here, the point. What's our y coordinate? It's 4. And the x coordinate is 6. So that means I'm going to do 4 divided by 6. That reduces. So think about how we would reduce this, what we divide on the top and the bottom. Okay, 2 goes into the top and the bottom, so that becomes 2/3. You can write this as a decimal, except it's repeating. So I prefer for you to write it as a fraction or keep it as a fraction. So our unit rate using the units is actually going to be 2/3 miles per minute. Since we took the y divided by the x, the y is the miles and the x is the minutes. So it's the miles per minute or the miles for every minute. Okay. So unit rate is as easy as just dividing two numbers together. And for the last, your turn here, we're going to be using slope to compare unit rates. So we're going to be really comparing two different things here. Number 4, the equation y equals 375x represents the relationship between x, the time that a plane flies in hours, and y, the distance the plane flies in miles for plane A. The relationship for plane B is in the table. We're going to find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying at a faster rate of speed. So we have y equals 375x, this one right here, and this k, since k is equal to 375, that's really your slope. Okay, so this is our slope of plane A. And this actually means, if I'm doing unit rate, it is the miles per hour. Okay, because the miles is y and the hours is x. It's always y divided by x. For table B, now there's a couple ways I can do this. If I know it's proportional, I can do miles divided by hours. I can do for each of them. So I could do, what the first one would be 425, that's miles, divided by hours. I can only do it if I keep getting the same constant ratio. So 850 in 2 hours means if I divide, I also get 425. And then 1,275, so I might need to bust out a calculator for this. But when I divide those, I actually also get the same thing, 425. And you're going to get the same thing for the last one, 1,700 divided by 4. So I'm not going to write it down. We see that here that our slope, or in fact, this is our k, which is the same as our slope. is 425, and this is miles per hour. So if plane A is 375 miles per hour, and plane B is 425 miles per hour, it says determine which plane is flying at a faster rate of speed. So this is our evidence to say that plane B is faster. Okay, so we've done the work, we've shown it, we wrote the both of these speeds. I wrote it again just to have it side by side, or one on top of the other, to make it for an easy comparison. But I have all the evidence there to show that plane B is faster. Okay, and that's all you need. All right, and that is it for lesson 3.3. Have a great day. Thank you for watching.